Alright, the last lesson for Chapter 8 is about complex numbers. So we're dealing with values where you have a square root of a negative number is what we're going to be looking at. Alright, so first off, I need to find an imaginary unit. Imaginary unit I is where I is the square root of -1. So anytime you have a negative under the square root, you just pull out an I. If you square an I, you would get -1 because if you think about it, square root of -1 times square root of -1, the square roots would cancel and you would get -1. So anytime you see a negative number inside the root, before we said if it was an even root, we couldn't do it. It wasn't real. Well, it's not a real number, it's an imaginary number. So we pull out an I. So for these examples, our first step, you pull out an I since we have a negative and a square root. And then square root of 25, do a factor tree if you need it. 5 and 5. Circle, circle, kill. So we end up with 5 and I. Answer is 5I. Same thing here. We have a negative, so we're going to pull that out on the outside. But this outside negative just makes our answer negative. So you have negative I times the square root of 81. And then 81 breaks up into 9 and 9. Circle, circle, kill. 9 goes outside, nothing left inside, so it's just negative 9I. On C, you could do a factor tree on 7, but you just get 1 and 7, so nothing simplifies there. But we can't take the square root of the negative out as an I. So we get I square root of 7. Now we typically like to put the I in front like a variable, so you don't have this idea that it's under the root. Same thing for D. We're going to pull an I out since there's a negative. We have square root of 44. Do your factor tree. 4 and 11. 4 breaks up into 2 and 2. Circle, circle, kill. 2 goes outside with the I, and you put it like you would an X. You put 2X, we're going to put 2I. Then square root 11's left over, so we put it under the root. So anytime you have a negative in the square root, we just pull out the I. If you have a negative outside, it just makes your answer negative. Sometimes you can multiply for it as well. But if you have a negative square root, you have to pull out the I before you multiply. Otherwise, you get some things that come out wrong. So here we multiply. We'll pull out the I. So you have I squared of 6 times I squared of 5. Then 6 times 5, we get square root of 30. I times I, we get I squared. Now 30, if you break it up 6 and 5, and the 6 breaks up into 2 and 3, 2, 3, and 5, we don't have any doubles. So that's not going to simplify. But I squared will. Because remember, square root of -1 times square root of -1 gave us -1. So this becomes a -1. And -1 times 30 is just negative square root of 30. Same thing on here. We pull out the i's times square root of 7. Notice I didn't pull out an I on this one because it's not negative inside the root. So 5 times 7, we get square root of 35. Root times a root's okay. Multiply outside numbers. I times 1. You could put a 1 there if you need to. Just gives us I. And since it's not square, we can't do anything with that. It's just I square root of 35. Example B, same thing. Pull out the I to start out. On this end too. Then we can multiply 8 and 6. We get square root of 48. I times I, we get I squared. I squared, we know, just makes it a negative. 48, if you do a factor tree, breaks up into 4 and 12. I'm going to go ahead and break up 12 into 4 and 3. Then I can see I have a pair. We have 2 3s. So circle, or 2 4s, sorry. Circle, circle, kill. 4 goes on the outside with the negative. 3 stays on the inside with the roots. So notice if it's both negative, we end up with a negative answer. If only one of them is negative on the inside, we end up with an I in our answer. If you went ahead and multiplied these, notice that we would have gotten positives, or square root of positive 30. And then we wouldn't have this negative out here. That's why it's important you do pull out the i's before you multiply. If you don't do that, you'll get the signs wrong. Same thing goes for division. Pull out the I first. Pull out an I here. And then you can divide the roots. So 80 divided by 5 would be square root of, well, 5 goes into 8 once, then 6, so 16. And then notice the i's are going to cancel. You have one on top, one on bottom. They cancel each other out. And square root of 16 is just 4. So 4 is our answer. Part B, you have to pull out the I before you can do anything else. So I square root of 40 over square root of 10. Now since we have 2 roots, none of them negative, we can divide. 40 divided by 10 is 4. So we have I times the square root of 4. And the square root of 4 is just 2. So we get 2i. Notice that all we've been working with so far is if you have an I in it. If you have both a real number and an imaginary number put together using addition, we call that a complex number. The part with the I is the imaginary part, and the part without the I is the real part. Right, so these would be complex numbers. We have a real part and an imaginary part. When you're adding and subtracting, you just add the real parts together and add the imaginary parts together. So negative 1 plus 9 is 8. Negative 8i minus 3i is minus 11i. Same thing here. It's kind of like adding like terms. Just kind of treat the I like you would an x. So negative 3, 1, negative 7, add up to negative 9, and 2i, 3i, minus 3i will be negative I, minus another 5i is minus 6i. So just combine like terms essentially. Remember, if it's subtraction, change this to addition, change each of these signs. So negative 1 minus, and a minus 4 is negative 5. Positive 2i and a negative I is just plus I. Same thing here, change signs. So 8 minus 12, negative 4, and negative 5i, and a positive 3i is a minus 2i. Now be aware, you're watching what these signs are. If they're addition or subtraction, you combine like terms. If it's multiplication, you have to use distributive property or FOIL. So here I'm going to distribute 6i. 6i times 4. 6 times 4 is 24. And then we keep the I with it just like we would with an x. And 6i times 3i gives us plus 18i squared. Just like if you did 6x times 3x. Now the only difference between dealing with i's and x's, if you get an I squared, you can change it to a negative 1. So 18 times negative 1 is just a minus 18. So this becomes 24i minus 18. Same thing, if you have binomials, treat like you would an x. This is an x, we'd think FOIL, so let's FOIL. 6 times 2 is 12. 6 times 4i plus 24i. Negative 4i times 2 is minus 8i. And negative 4i times positive 4i It's minus 16i squared. Remember, this I squared becomes a negative 1, so this is going to change to a plus 16 right here. And then 24i and negative 8i, those are like terms, so we can add them. 24 minus 8 is 16i. And then we have the plus 12. We now see, since this changed to just the plus 16, we can combine it with the plus 12. We get 28 plus 16i. So anytime you do FOIL here, you usually end up with an I term and a real term, an imaginary part and a real part. Let's try another example. FOIL this, we get 3 times 3, which is 9, outer, plus 12i, inner, plus 6i, and last, plus 8i squared. So this looks a lot like what we do with x's, but remember, this I squared changes it to a negative, so this becomes minus 8. 12 plus 6, we get 18i, and we bring down the plus 9. Combine like terms, 9 and negative 8 gives us a positive 1. So there's a real part, or imaginary part is 18i. You'll always have a real part and an imaginary part. One of them could be 0, but you always have both. Alright, so anytime you have the difference of two squares, essentially, and a number plus a number I, and then the same numbers but minus, what that ends up doing is it gets rid of these i's. So anytime you need to get rid of an I, you multiply by the other one. We call that the same numbers but different signs. We call those conjugates. So if we need to get rid of this I down here, we multiply by the conjugate, which is 4 plus 3i. All right, on the top, if we use FOIL, we get 24. Outer, we get 3 times 6, we get 18i. Inner, 2i times 4, we get plus 8i. And then last, 2i times 3i gives us plus 6i squared. On the bottom, on the FOIL, we get 4 times 4, which is 16. Outer, plus 12i. Inner, minus 12i. And last, negative 3i times 3i is minus 9i squared. And then we simplify. So on the top, this becomes a minus 6 because we have an I squared. This becomes a plus 9. Let's combine some like terms. 24 minus 6 gives us 18. 18i plus 8i gives us 26i. On the bottom, 16 plus 9 is 25. And then the i's cancel. 12i minus 12i, those cancel each other out, which is just what we wanted because we don't want any i's on the bottom. Now typically when we'll write this, they'll write it out as a division problem so that you divide both top numbers by the bottom number. So you end up with 18 over 25 minus 26 over 25i. So then you can see very clearly, this is your imaginary part, this is the real part. This is how they usually write your answers with imaginary numbers. We will finish this lesson on the next video since we're about to run out of the 15-minute time limit. And then you'll be done with lesson 7.